5.2 bisectors of a triangle. So there's two different types of bisectors that we're going to be talking about. The first is a perpendicular bisector. Remember, a bisector means you divide segment, in this case it's a segment, into two congruent parts. And this one will be divides angle into two congruent parts. Okay, so this has to be congruent to that for it to be a bisector. Also, perpendicular means forms a right angle. It has to do all, divide it in half, and form a right angle. Where the angle bisector, this angle has got to be congruent to this angle. Okay, so it's important to be able to identify what these look like, because now in this section we're going to talk about two new theorems, and I have another GeoGebra file here to go through these. Alright, so the first theorem is the concurrency of perpendicular bisectors of a triangle. And I can move points A and C around in GeoGebra here. And we can see that these perpendicular bisectors, I know my cursor here is not very big, but hopefully you can see the segment here is the perpendicular bisector of segment AB. This line is the perpendicular bisector of CB. Notice it still goes through this opposite side, but we don't worry about that intersection. We're worrying about this intersection. And as I move these points around, notice the perpendicular bisectors always, all three of them, meet at the same spot. Okay, and I can even bring B close to point C, and the perpendicular bisectors are meeting outside of the triangle. It's still a center of the triangle because it is the center of a circle that goes through and intersects all 3 points. If you think about a circle, these red lines are all radii. That's the plural of radius. They're all radii of the same circle, so they all are congruent. So this center is called a circumcenter because it goes around, like circumference. That prefix cir means goes around. So this is the circumcenter, and sometimes it's inside the triangle when it's acute, and when I make a right triangle, this angle right here is a right triangle, the circumcenter is on the side, and obtuse triangle is on the outside. Okay, so the perpendicular bisectors make a circumcenter. The perpendicular bisectors are concurrent, which means they all intersect, all 3 lines intersect at one place. So that's the first theorem of the section. The second theorem is about the angle bisectors. So in this case, this angle is congruent to that angle. These blue lines are the angle bisectors. The red lines are just a perpendicular line. So basically from where the blue lines are concurrent, the point of concurrence C, the blue lines, to the side of the triangle. Those are radii of the same circle. So the red lines again are going to be congruent. Notice these blue lines, it's always going to be an angle bisector even if I change the shape of the triangle. Notice I have an obtuse triangle here, and I can move it around to an acute triangle. That in center, this is called the in center, the circle is on the inside of the triangle. The in center is always on the inside. Even when you have an obtuse triangle, it's still on the inside because you're dealing with angle bisectors. So hopefully that kind of makes sense. So back to the notes. Concurrency of perpendicular bisectors. I got some pictures. These ones aren't as nice because you don't get to move them. The red segments are all equal. in both pictures. Okay, that's kind of what the theorems are basically saying. The one thing I want to note on this is this there, that is called the circumcenter. Okay, the circle is going around the outside of the triangle, and this center is called the incenter. The circle is inside the triangle. So if you're given a picture, they might not always tell you what's going on. You got to kind of look at it, and right away I see these blue lines. That is not an angle bisector. How about the red lines? And the red line looks like it's in the middle. This segment's about the same length as that. That looks like a right angle. So right here I'm seeing perpendicular bisectors, these red lines. So that means I have a circumcenter, which means these blue lines are all the same length. Okay, here the blue lines are not all the same length. It's the red lines that are all the same length. We have angle bisectors making an incenter. Okay, so it's important to kind of figure out which segments are the same length to solve problems like this on the next page. So on this page, we're given angle bisectors. So that clues me into that this is a incenter. Kind of a bad drawing, but you get the point. These are the radii of all the same circle, so they're all congruent. So when they say find OA, OA is this segment, it's going to be the same as these two segments. So if I found one of the others, they're going to be the same. Now OB is not necessary. We're going to have to do some math to figure that out. So the first thing, instead of finding this segment, I'm going to find this segment by using the Pythagorean theorem. I have a right triangle with sides of 15 and 17. I'm going to use Pythagorean theorem, a squared plus b squared equals c squared. Now, my hypotenuse is c. I put that in, and 15 in for a or b, it doesn't matter. And now I have to solve for the other one. 15 squared is 225 plus b, oh, I missed the square up there, b squared equals 17 squared, I believe is 289. And so now I subtract 225 from both sides, and I get b squared equals, give me a second here, 64. So take the square root now of both sides, and you get 8. Okay, we don't have to worry about plus or minus because we're talking about distance. This length is 8. And so therefore, segment OA has a measure of 8. Okay, so that segment and that segment were congruent. So now to find OB, I get to use the Pythagorean theorem again, but this time I have two legs. So 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. That's going to be 100 equals c squared. And take the square root of both sides. C equals 10. Okay, so therefore OB equals 10. So notice the picture's not really drawn to scale. Sometimes that's the case, not very often. There's your homework assignment. I'll see you in class.